All right, here's problem 1 from problem set 2. So let's read through this. This is a spider and ant problem. Spider is located at position 1, 2 in a coordinate system where the units on each axis are feet. An ant is located at the position 15, 0 in the same coordinate system. Assume the location of the spider after 2 minutes is given by s of t equals 1 plus 2t, comma 2 plus t, and the location of the ant is at a of t equals 15 minus 2t, comma 2t. Alright, so part A is asking us to sketch a picture of the situation, indicating the location of the spider and the ant at these times. We need to label the location of the bugs and so on. Okay? Alright, so we need to make a coordinate system. Let me see if I can switch this up. Alright, so let's go over here. Let's see if I can draw a straight line. I'll have to do my best here. Alright, this is the best I can do. Alright, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then here too. Some markings. Okay, hopefully this is enough. Okay, so now to help us keep track of what the spider and ant are doing, I'm going to make a table here. So I'm going to make a table with time in the first column, and then we want to graph this in the xy plane. Okay, so we want the x value and we want the y value. And so let's do this for the spider. Alright, and we want, maybe I should make a bigger table because I want to have both of them together so we can compare. So I redraw this a bit smaller. So I have the time. We're going to do for the spider here. We have the x and we have the y. And then let's do for the ant here. We have the x and we have the y. Okay, cool. So let's go back up and see. So the spider starts at 1, 2, and the ant starts at 15, 0. So that's when the time is 0. Okay, so when the time is 0, that's their starting point. And these right here tells us how the x and y values are changing for the spider. So you see it's like a coordinate plane because it has the coordinate point because it has the comma between. So this is like the x and this is the y. So we can actually kind of write the equation like this. So the x coordinate of the spider is given by 1 plus 2t. So it changes as the time goes by. Let's try that again. Is 1 plus 2t. And the y coordinate of the spider is given by 2 plus t. So this will help us figure out the location of the spider with each passing second. The ant is given by this. So this is the x and this is the y. So the ant, we have x is 15 minus 2t. And the y equals 2t. Okay. Cool. So now we want to know the location of both the spider and the ant for t is 0 through 5. Okay, so let's go back here. We have t 0 and 1 and 2 and 3 and 4 and 5. Okay, I'm going to do different colors. So when time is 0, we plug in the x and the y equation. So 1 plus 0 is 1, and 2 plus 0 is 2. So this is the starting point as it was given. Why is it putting an arrow at the end? It's weird too. Okay. Oh, I see. I think that's the type of pen that I chose. Let me see if I can change colors for this one. There you go. 1 and 2. So 1 and 2, this is the starting point for the spider. So this is like S at 0. Alright, let's follow the spider to start with. So plug in T is 1. So T is 1, we have 1 plus 2 gives me 3. 2 plus 1 gives me 3. So the next part is 3, 3. So this is S at 1. Alright, at 2, 1 plus 4 is 5. 2 plus 2 is 4. So 5 and 4. This is S at 2. At 3, 1 plus 6 is 7. And 2 plus 3 is 5. You can see that this is increasing by 2. This is increasing by 1. So we can like do it like that way instead of plugging in each time. At 4, this is going to be 9 and this is 6. And at 5, this is going to be 11 and this is 7. 11 and 7. So you can see it's moving, this is a 5. It's moving along a straight line. This time is going by and it's going to follow that straight line. Okay? Alright, let's do the AND. So the AND, if I plug in T0 for the x and y equations, I get 15 and 0, as we were told. So it starts right here. This is A at 0. When time is 1, when we have 15 minus 2, we get 13. And this is 2. So we have 13 and 2. A at 1. And then, when t is 2, we have 15 minus 4, which is 11. 2 times 2 is 4. So this is going down by 2, this is going up by 2. So 11 and 4. Okay, that's A2. And go down by 2, up by 2. 9 and 6. Alright. And then down by 2, up by 2. 7 and 8. And then 5 and 10. I think this was probably here. Okay, so that's A5. Alright, so this is the line that describes the path of the AND. Okay, so you can see that they're going, so each other's paths are crossing, but they're not getting to the crossing point at the same time, right? So this is S at 4, so the spider gets there at 4 minutes, and the ant gets there at 3 minutes. So the ant gets there like before the spider does, so they're not there at the same time. Okay. Okay, so let's see. Okay, so this was part A right here, which was figuring out the path of the spider and the ant and labeling the graph. And this is the part that's going to take the longest. The others are a little bit shorter. All right, part B. When will the x-coordinate of the spider equal to 5? When will the y-coordinate of the ant equal to 5? Okay, so we can answer this question in a couple of ways. One is to look at our table and our graph, see if it's there. Okay, so the spider, the x-coordinate of the spider equal to 5 when t equals to 2. The y-coordinate of the ant equal 5, so the ant, the y-coordinate equal 5, it's not in the table, okay? But it's going to be sort of somewhere in here, somewhere between, well, halfway between 2 and 3. So you can sort of estimate that it's going to be 2.5. Okay, so this is sort of using the table, or even you can look at the graph. Another way of doing it is by solving equations, because we have equations for the x-coordinate of the spider. So the x-coordinate of the spider is given by 1 plus 2t. And it's asking us, when is this going to equal to 5, right? So you can just set that equation equal to 5. You get 2t equals 4, so t equals to 2. Okay, right? So you can find it algebraically rather than looking at the table. And the same for when will the y-coordinate of the ant equal 5? So the y-coordinate is given by this equation, 2t. We want to figure out when that's equal to 5. Divide by 2, so t equals 2.5. Okay, and this is in minutes. This is in minutes. Okay, so this is a strategy we're going to use, like looking at the equations for each of the coordinates. Okay, let's look at part C. Where is the spider located when its y-coordinate is 3? Okay, we can look at the table. So the y-coordinate of the spider is 3, and the x-coordinate is 3. That happens when t equals 1. Okay, so where is the spider located? At 3, 3. Part D. Where is each bug located when the y-coordinate of the spider is twice as large as the y-coordinate of the ant? Let's see if we can figure out from the table. If not, we can see. We have the y-coordinate of the spider is twice as large. It's twice as large here, isn't it? Okay, let's do it with the equation, because it's fun. You can see how you can use the equations. So we're trying to figure out the y-coordinate of the spider, which is 2 plus t, is twice as large as the y-coordinate of the ant. So it's 2 times 2 t. Okay, so we can solve this equation. We have 2 plus t equals 4t. We get 2 equals 3t. We get t equals 2/3. Okay, so you can see that kind of looking at the equations is better, because at the table they're like not like 4 and 2, like this is twice as big as this one, but they're not occurring at the same time. So we're trying to figure out where each bug is located in the same point in time. Okay, so from here, let's continue D down here. We got t equals 2/3. Then we can figure out the coordinate of the spider. Alright, the x value is given by 1 plus 2t. So we have 1 plus 4/3. The y coordinate is given by 2 plus t, which is 2 plus 2/3. And just simplifying this, we get 7/3 and 8/3. Okay, so this is where the spider is. Okay, the ant, looking at the equations, 15 minus 2t, so this is 15 minus 4/3, and 2 times t, and 4/3. So we have, it's 15 minus 4/3, it's like 1 1/3, 14, it's like 13 and 2/3, and 4/3. Okay, cool. Let's look at the next one, E. How far apart are the bugs when their x-coordinates coincide? Draw a picture indicating the location. So x-coordinate coincides means the x values are the same at the same time. So we don't want to look. Let's look at the equations again. Okay, so the x coordinates coincide means the x-coordinate of the spider, which is 1 plus 2t, is going to equal the x-coordinate of the ant, which is 15 minus 2t. So we have, at this, we have 4t equals 14. So t is going to be 14 over 4, which is 7.5. Okay? So let's figure out the locations of each at t equals 7.5. The spider is at 1 plus 2 times 7.5 is 15, and 2 plus 7.5, which is 9.5. So we have 16 and 9.5. The ant, 15 minus 15 is 0. Did I mess this up? The x-coordinates coincide. Oh yeah, 14 divided by 4 is not 7.5. 14 divided by 2 is 7. 7 divided by 2 is 3.5. That's what I meant. I can do arithmetic. Let's fix this up. So this is 3.5. Okay, so let's go back here. 1 plus 7 is 8. 2 plus 3.5 is 5.5. And here, 15 minus 7 is 8. Good. So we need the x-coordinates to be the same, because that's where we came from. Okay. Cool. So, looks like this is happening, the green, when t is 3.5, the spider is at 8 and 5.5 here, and the ant is at 8 and 7 here. So the distance between them is like vertical, up and down like this. So it's basically 7 minus 5.5. So they're 1.5 feet apart at that point. Okay, so you can just, because it's like they have the same x-coordinate, it's a vertical distance, you can just figure out by subtraction. Alright, let's look at F. A sugar cube is located at the position 9, 6. Explain why each bug would pass through the position of the sugar cube. Which bug reaches the sugar cube first? Alright, so looking at the table, we can see that 9, 6 is here. So the spider reaches it at time 4. That's S4. And the ant, 9, 6. This is basically where they're crossing here. The ant reaches it at time 3. Okay, so you can, the explanation is that they're passing because they're both coordinate points in the table. It fits with the equations, and you can tell that the ant reaches it first because it happens at t is 3, and this happens for the spider at the time is 4. Alright, part G, find the speed of each bug along its line of motion. Which bug is moving faster? Okay. Alright, so we gotta figure out how fast the spider is moving and how fast the ant is moving. So we can look at the speed is, we can figure out the speed using distance equals rate times time. Right, so the rate is distance over time. Okay, so we can figure out how, since they're going against a straight line, the speed is going to be constant. It's basically the slope of the line. You can also figure out, let's find how much distance they're covering in one minute. Okay, so we can look at the distance between this point right here and this point right here. So if I'm looking in the table for the spider, it's going from 0.12 to 0.33 in 1 minute. Okay, so I'm looking from 0.12 to 0.33. So we can figure out this distance with the distance formula. We have x1 minus x2 squared and y1 minus y2 squared. 1 minus 3 squared plus 2 minus 3 squared. This gives us 2 squared, which is 4, 1 squared, which is 1. So this is square root of 5 feet in 1 minute. Okay, so that's the speed here. And this is approximately, if I do square root of 5, (2.23) feet per minute. Okay. All right. Now let's look at, so that's the spider and ant. Okay, so the ant, let's do the same. Let's look at the first 2 points. So 15, 0 and 13, 2. Find the distance. So 15 minus 13 squared and 0 minus 2 squared. 4 and 4. This is square root of 8. Right, so square root of 8 is 2.83 feet per minute. Okay, so so it looks like the ant is moving faster. Okay, you could probably already tell that because like the ant's slope is more inclined than the spider slope. Alright, so this was kind of a neat problem to show you how you can graph and plot points that turn out to be straight lines, but it shows the movement of these bugs. These are called parametric equations because it sort of doesn't only give you x and y coordinates, but there's a third parameter, the time, that kind of gives you more detail. It helps you sort of guide you with each passing minute what's happening, and then figure out information from the graph, the table, and the equations. All right, that's it for this one.